Okay, so our goal here is to start development on an application that we can use as a system monitor. So our first steps here are going to be to actually grab system information from our system using a couple libraries and some structures. Okay, all right. So before we start creating our application that gathers system information, we need to understand what a struct or structure is. And there's a little bit of a historical context here, where the concept of a struct originates from the C programming language, and it served as a means to group related data. C++ inherited this construct to maintain compatibility with the C code base. The class keyword was introduced in C++ to support object oriented programming features like encapsulation and inheritance. But over time, the functionality between struct and class have diminished, with the primary distinction actually just being the default access specifier. So in C++, a struct is a user defined type that groups related variables or members under a single name. While, while in syntax, it's similar to a class. The key distinction lies in the default access specifiers. Members of a struct are public by default, whereas those of a class are private. So both a struct and a class contain member functions, constructors, destructors, and support inheritance. The choice between them often is reflected in the design intentions rather than the technical necessity. So, when are we going to use structs or structures? Well, while a struct and a class are functionally similar, conventions guide their usage. So, you're going to use a struct for plain old data, POD, types that primarily store data without complex behavior. When interoperability with C code is required to represent simple data aggregates where all members are public. You're going to use class when encapsulation of data and behavior is actually necessary. For types that involve inheritance or polymorphism, and to implement complex abstractions with private or protected members. So these conventions aid in code readability and convey the programmer's intention. But why are we going to even use structs? You got to know the benefits, right? So, simplicity, it's ideal for grouping related data without the overhead of encapsulation. Interoperability, because it facilitates interactions with C libraries and APIs. Clarity, because it conveys that the type is a simple data holder. And aggregate initialization, because it allows for easy initialization when brace enclosed lists. There's some best practices here too, like remaining consistent or consistency. So you want to adhere to the convention of using struct for passive data structures and class for active objects with behavior. And for encapsulation, use access specifiers such as private, protected, and public to control member access explicitly. You're going to initialize, so your initialization where you're going to leverage aggregate initialization for structs to simplify the object creation, and then obviously clearly document everything.